Hello everyone. I'm trying to explain how to calculate electrical charge in the oil drop experiment performed by Robert Millikan in 1909. In the experiment, oil drop is falling without applying electrical field because of gravity. And in this case, the drag force will be applied opposite gravity. And because the shape of the droplet is a sphere, the weight of the oil drop is the volume of the drop is 4 over 3 times pi r cubed, and the apparent density and gravity is multiplied to find the weight of the oil drop. And this apparent density is the difference is the density of the oil and the density of air. And drag force is 6 pi times the radius and Greek letter eta and the first terminal velocity. The Greek letter eta is for the viscosity of the oil, and at the terminal speed these two forces are in equilibrium, so we can make the equation showing gravity is the same as the drag force. And we can simplify this equation and solve the equation for the radius. So r squared is 9 over 2 times this, and if we take the square root, our radius is this expression. And now we can substitute this expression for r to find the weight of the oil drop. So the weight is this times r cubed and now we can cancel these two and simplify the numbers. One good thing about this is that we don't have to measure the radius of each droplet to find the weight of uh, the drop. Um, if we would measure the each radius, it will be tedious and inaccurate. And now let's apply the electrical field between these two plates. Distance of the plate is d, and the voltage applied is V. And if the electrical force is greater than the gravity, the oil drop will move upward. And in this case, the drag force is applied in the same direction with the gravity. So we can make a new equation. And if the droplet is reached at the second terminal velocity, the electrical force is the sum of the gravity and the due drag force. And the electrical force is the product of the electrical charge and the electrical field. And for the drag force, we are going to use the second terminal speed. And we can change this expression to the weight over the first terminal speed measured in the first situation. And electrical field is the voltage divided by the distance between plates. And we can factor the right expression with the weight. So now we have the expression for the electrical charge of the oil drop. And if we use the expression for the weight of the oil drop in the first situation, the electrical charge is determined with this expression. Because other values are predetermined before experiment, Uh, During experiment, we are measuring three things. The first, terminal speed, and the second, terminal speed, and the voltage applied uh, when the second terminal speed is reached. And the result of this experiment show that uh, this electrical charge uh, is always a multiple of a certain value, like this. And this E is the electrical charge of an electron. So using this experiment, we are able to determine the value of electrical charge of electron, and at the time, the ratio of a charge to mass ratio of an electron was known by J.J. Thomson uh, experiment, another experiment. Uh, if we know the value of electrical charge of an electron using this ratio, uh, we can also identify the value of mass of an electron. So that's it for this video, and thanks for watching.